All right, we're given at the beginning of an experiment, a scientist has 284 grams of radioactive goo. After 105 minutes, her sample has decayed. So this is going to be exponential decay, which is the formula P of T equals P of 0 e to the kt, where this P of 0 is the initial, and we're given that. We're given P of 0 is 284 grams, so that's what's given right here first. It says at the beginning. And then after 105 minutes, it decays to 8.875 grams. So this is the information given to us. What we can do with this is we can plug these values in to solve for K, and that's kind of the point we want to get with a formula that we can plug in any T. So we need to solve for K first. So the first thing that I would do is for P of T, I would put in 8.875. We know our initial is 284, and then E, our T is 105, and then we want to solve this for K. So to solve for K, I would divide 284 on both sides. And I'm going to just keep these values because I don't want to lose my decimals. So you'll see how I'll put it in the calculator here in a second. And so I'm left with this e to the 105k. Remember now, if you ln both sides, so I'm going to ln the natural log, then what happens, come back up over here, is I have ln of 8.875 over 284. The ln cancels this out, brings the 105k down, and now I can divide both sides by 105. So if I take this and I put it in my graphing calculator, so whatever you're using for your graphing calculator, I'm just going to use this website. I'm going to put in ln parentheses 8.875 divided by 284. Be sure in your calculator you go outside the parentheses, and then you get this value right here. So what is that value? That is the actual K value. So now I can actually write my function as P of T equals, my initial doesn't change, 284, e raised to that K value you saw, negative 0.0. Uh-oh, I looked down and moved my pencil. 0.33007t. All right, I'm going to write it on this next page because then we want to find the half-life. This right here is this formula. Okay, so they're using G of T for grams. So let me just rewrite that. So I have my G of T equals my initial 284 e to the negative 0.0330007t. Now the next thing it asks me to do is to solve for the time when it's at a half-life. Well, when it's at a half-life, it's when 284 is cut in half. So that would be 142, right? 284 divided by 2, cut in half. 284 e to the negative 0.033007t. If I divide both sides by 284, you can kind of see I'm going to be doing the same thing as I did on the other one. ln now of 142 divided by 284. Be sure that's in parentheses, and when I ln, I'm going to divide by this value, 007. Because when I ln this side, ln of e to the negative 0.0330007t, That cancels out, and this comes down, and I'm solving for t. So if I get my calculator back, I can find it here, and I put in my ln, and go to the side so you can see it, 142 divided by 284. On the outside, divide negative 0.033007, and I hit evaluate. You can see that I get 21 for that half-life. Now this last part, all you're going to do is, it says after 68 minutes, is you're just going to simply take your equation. Let me go back here so I can see it up there. And you're going to plug in, I already forgot the number, 68. And so all you're doing is taking this and you're plugging in 284 e raised to the negative 0.033007 times 68, and this will tell us the grams, and we would expect that it's getting lower since it is decaying.